In the definition of power series, a power series is defined as, or basically a p-series is defined as the summation of 1 divided by n to some power n to p, which is convergent if p is more than 1, and it is divergent if p is less than equals to 1. For example, in the case that n is equal to 1, we know that we have a harmonic series. By definition, you have the summation of 1 divided by n. N starts from 1, goes to infinity, and if you just start adding the terms of this series, you have 1 divided by 1 plus a half plus a third plus a fourth plus the rest of the terms. And if you add these numbers together, it starts getting larger in size. It goes to infinity. And you end up with a divergent series. So harmonic series, an example of p-series, which is divergent. What if we have n equals to 2? If n is equal to 2, you have the series of 1 divided by n squared. N starts from 1, goes to infinity. How do we deal with this series? We remind ourselves of the integral test. In integral test, we had the following scenario. Let sigma an, n starts from 1, goes to infinity, be a series. If f of n or an is positive, continuous, decreasing on the interval 1 to infinity, then we have the following scenario. The integral of f of x dx from 1 to infinity is convergent if and only if the series of an, n starts from 1, goes to infinity, is convergent. So can we apply integral test here? You need to check each one of these conditions. Is the function f of x equals to 1 over x squared a positive function? If you visualize this function, the graph of this function behaves like this. It has a vertical asymptote when x is equal to 0, but for the rest, the graph behaves like this. So let me use a different color here for you guys. Okay, here we go. So this is the behavior of this function. So obviously, from 1 to positive infinity, this guy is continuous. This is continuous, this is positive, so we can check to see it is positive or not. It's positive since it is above x-axis, or it is on the positive part of y-axis. So definitely it is positive. Is it continuous? It is continuous on 1 to positive infinity. It only has one vertical asymptote. So indeed, your function is continuous on 1 to positive infinity. The second condition is met. What about the third condition? Is it decreasing? To check to see if it's decreasing or not, you need to take the derivative and show that the derivative is negative. So the derivative of this function is 0 times x squared minus 2x divided by x to the fourth. Or the derivative of the function is equal to minus 2x divided by x to the fourth. Don't simplify this. Do not simplify. Why is that? Because your denominator already has exponent 4. So this guy indeed is positive. On the numerator, here you see you have negative 2x. Negative 2x is decreasing. It's negative. It is negative on 1 to positive infinity. So what's the meaning of that? It means that the whole fraction is negative. So since f prime is negative, it means that the function is decreasing. F prime is negative. The function is decreasing. All three conditions are met. So to check this series to be convergent and divergent, we can take the integral. Since all three conditions are met, we can convert our series to the integral. The integral of dx divided by x squared, x starts from 1, goes to infinity, is very easy to calculate. This is negative 1 over x. X starts from 1, goes to infinity. So if you plug in infinity, you get negative 1 over infinity minus negative 1 over 1, or 0 plus 1, or 1. So what do we have? Our integral converges to 1